Richard James will present to you Factorization Tutorial 4. Do not be frightened by the presence of p cubed. For sure, the expression is not a difference of two squares. Neither term is a square. However, no one can deny the presence of the common factor of p. So, cannot deny that p is present in both terms. And some individuals watching these videos may come to the conclusion that I'm a bit overbearing, mentioning all the time that such and such expression is not a difference of two squares. However, most expressions that have two terms are mistakenly identified as a difference of two squares. And we can see that in the attempt that some candidates make in factorizing each expression that has two terms, that is a binomial, as they would be expected to factorize a difference of two squares. So I'm always guarding against students taking up every single expression and factorizing them as a difference of two squares for that particular reason, because I see that happening very, very often. Now we have p cubed minus p, and for sure there's a common factor of p, so we'll make use of the common factor. Every time you are attempting to factorize an expression and you see that the terms have a common factor, whether you have two terms, three terms, five terms, as long as there is a common factor, always go to first principle. Take a common factor and divide each term by the highest common factor. So there we have p is our common factor, and we will divide each term by p, and we know that p cubed represents three occurrences of p. If we divide by p, one of them is gone, we have two left. Two occurrences of p, p squared. And of course, p divided by p, any number or expression divided by itself is equal to 1. So we are expecting to see p squared minus 1. So p cubed divided by p is p squared, and p divided by p is equal to 1. So we have there p squared minus 1. And of course, p squared minus 1 is in the form of a difference of two squares. Therefore, we may go straight ahead and factorize this expression as we would any difference of two squares. So, don't be perturbed by the appearance or the first appearance of a particular expression, as long as it can be factorized by taking a common factor. Then go straight ahead and take your common factor. And that we have done already. The difference of two squares. How do we factorize the difference of two squares? We will factorize the difference of two squares. We will factorize the difference of two squares by taking the square roots of the two squares. So let us go straight ahead and do that. The square root of p squared is p. The square root of 1 is 1. And as usual, we place them in brackets and we separate them by a positive sign in one pair and a negative sign in the other. And that's all there is to it. Insert those signs, a positive and a negative, or you may say a negative and a positive. As long as one is positive and one is negative, then we will be correct. Whenever you come across a problem that appears a bit awkward to factorize, always look for and be prepared to make use of a common factor. Because maybe we will not see an expression like this one, a binomial with a single cube, and then something else. When you come across any expression, no matter how awkward it looks, always be prepared to make use of the common factor. Factorize this expression by grouping by first taking a common factor of 3x. And how do we know and we are able to identify an expression in the examination that we will be required to factorize by grouping? First of all, if grouping is possible and we are going in groups of 2, then the number of terms must be a multiple of 2. And as a matter of fact, at this level, the maximum number of terms given in an expression for us to factorize in a polynomial is usually 4. And we know that we take them 2 by 2. And if they are 3, then we expect the expression to be a trinomial. It may not be a trinomial, but we expect an expression that appears in 3 terms to be trinomial. And we factorize in the normal way that we will factorize a trinomial. But maybe the examiners will be a little bit experimental, throw in an expression with 3 terms that we might not be able to factorize in the same way that we normally factorize a trinomial. What do? Surely, if it cannot be factorized in a normal way that we will factorize a trinomial, it has to have common factor. Therefore, we will factorize by taking a common factor, and after so doing, then we might end up with another expression of which the factorization will be familiar. But always be on the lookout for common factor and be prepared to use a common factor at every stage of the way. So we have that expression, and the first 2 terms have a common factor of 3x. And if so be the case, we will take our common factor of 3x and we'll always write it right there preceding our brackets. And what do we do next? We will divide each one of the terms that we have by the highest common factor of 3x. And if we take a common factor of the second 2 terms, the second pair has a common factor of negative 2y. What do? Always factorize by taking the highest common factor and also dividing each of the terms by the highest common factor. So divide by 2y. And what do we know now? For that one, we say 3x. The x's will cancel, and 3 into 6 is 2, so we expect 2n. Here we have the x's will cancel, and 3 into 9 is 3, so we will have 2n minus 3. So 6nx divided by 3x is equal to 2n, and negative 9mx divided by 3x is equal to negative 3m. As we see, the x's cancel. 3 into 9 is 3. Nothing to cancel the m. We have 3m. And x's will cancel here. 3 into 6 is 2. So we have 2n right there. Right. And what about the other one? Of course, negative into negative is positive. The y's will cancel. And the 2 into 4 is 2, so 2n. And here we have 2 into 6 is 3, and the y's will cancel. But do not forget that we are dividing a positive by a negative, so the result will be negative. So we have 2ny divided by 2y. Of course, we have negative divided by negative. Negative 4ny divided by negative 2y. Y's are gone, and we have a positive 2n. Here we have 6my to be divided by a negative 2y. So we'll have a negative 3m. The y's will cancel. 2 into 6 is 3. And the resulting common factor is, here we have it, 2n minus 3m. So that is our new common factor. 2n minus 3m is common. And what do? As usual, we divide each term by the highest common factor. And we'll divide by 2n minus 3, 2n minus 3m. And this is what we get. Taking, then we have 3x. And then doing the same here, and we are left with negative 2y. Immediately, there should not be any doubt that all that we can do with this expression is take a common factor. Additionally, the highest common factor is quite obviously x. So all that we can do with this one is take a common factor, because there's nothing that looks like a square here or here. So take a common factor of x, and when the x cancels, 3y will be left, and x into x is 1. So we expect 3y minus 1. So divide each term by the highest common factor. 3xy divided by x is equal to 3y. The x's will go, 3y will remain, and any number or expression divided by itself is equal to 1. So x divided by x is equal to 1. And not neglecting the negative sign, negative x divided by x is equal to negative 1. So we cannot deny that we have a negative sign present right there. Like in the previous tutorial, here we have another problem with a portion of it already in factors. As we discovered, it was to our advantage to cause the factors to remain. On this occasion also, we will cause the factorized portion to return as it is. For the other portion, we will take the highest common factor of negative 1. So in this particular case, we have a portion of the expression already factorized, or already in factors. Here we have it. And then we have this one that is not factorized as yet. Now, what some candidates may opt to do is expand the brackets, and after expanding the brackets, put the terms together, and maybe we will have a nice quadratic form that we may be able to factorize immediately, or we'll end up with a trinomial that we have to resolve the middle term into its two components again. So either one that I've just mentioned is somewhat more time, at least more time consuming than the way that I have proposed that the problem could be solved. So let us go straight ahead and do not disturb the x minus y all squared, but carry it along with us, and then take a common factor of negative 1 for the other pair. And what do we say? Negative into negative is positive, so positive x, and negative into positive is negative, so a negative y. Positive x, negative y, x minus y. So negative x divided by negative 1 is a positive x, and positive y divided by negative 1 is negative y. We have them right there. And I am sure that we can see now a common factor x minus y. X minus y. So finally, the common factor is x minus y. X minus y is our common factor, and we will divide each term by our common factor. So go straight ahead, divide by our common factor. what will happen? So we have no doubt x minus y all squared right there. That is telling us that we have two occurrences of x minus y multiplying together. So if we cancel one of them, then one will remain. So if we say x minus y all squared divided by x minus y, we will get x minus y, because we are cancelling one of the two occurrences of x minus y that we have multiplying together in that numerator. And over here, no difficulty, these two are gone and the result is -1. So we have right there x minus y, and we have here a -1. And we may make use of a simple result. X squared divided by x is equal to x. Therefore, something squared divided by something is equal to something. So x minus y all squared divided by x minus y is equal to x minus y. So that is a bit clearer to us now. Make light work of the factorization of this difference of two squares, especially that the exact same problem is on a previous tutorial. So on a previous tutorial we have this exact same problem, so we may just go straight ahead. And I think that we have seen this one also already, so we do not have to beat around the bush. So 4x squared minus 9, difference of two squares. Proceed by finding the square roots of the squares. They will be enclosed in brackets and be separated by a negative sign in one case and a positive in the other. So square root of 4x squared is equal to 2x. Square root of 4, 2. Square root of x squared, x. Square root of 9 is equal to 3. And we will what? Separate them with a positive and a negative sign, like so. So we have 2x minus 3, 2x plus 3. Those are the factors of the difference of two squares. Let us factorize by grouping, by first taking a common factor of q. So we have another expression given to us in 4 terms. And usually when one is given to us like that in the examination, we expect that we should factorize by grouping, by taking 2 at a time, and we take the factor or the highest common factor of the first 2 terms to be q. We go straight ahead and we say divide each term by the highest common factor of q. See, we take our common factor of q. Some students, after taking the common factor of q or whatever they take it to be, they do not include it in the next step. That is not correct, because if we try to expand the expression in the end, we will not go to the original or return to the original. So let us continue. We are dividing each term by the highest common factor, and I am saying also that we do not omit the highest common factor in any of the stages, so we will carry the highest common factor along with us. Each term is divided by the highest common factor, and then we go straight ahead, take the highest common factor of 6p and 2. Well, the highest common factor of 6 and 2 is 2. There's no p in this one, so just 2. The second pair has a common factor of 2, as we said before, and we will divide each term by the highest common factor of 2. Well, we are going to be a bit technical about it now. Q will cancel Q, and we have 3p, and anything divided by itself is equal to 1. So 3p minus 1. And here we have 2 into 6. 2 into 6, 3, and nothing to cancel the p. It goes back, so there's a 3p, and anything divided by itself is equal to 1. But let us take a look at this one first. So we have 3p, q divided by q is 3p, and q divided by q is 1. So those q's are gone, 3p. And those q's are gone, anything divided by itself is 1. Over here, we do the same. 6p divided by 2, and 2 divided by 2. 6p divided by 2 is 3p, and 2 divided by 2 is equal to 1. So 3p and 1. And at this stage again we have a common factor of 3p plus 1. Make use of that common factor of 3p plus 1. So our common factor is 3p plus 1, and we will divide each term by the highest common factor of 3p plus 1. Do not forget that when we take our highest common factor, we carry it along with us, meanwhile dividing the terms by the highest common factor of 3p plus 1. So those will be cancelled, and of course, see, we are carrying our common factor along with us. And what will remain? Q. And when these go, what remain? 2. So q plus 2. In this problem, the first term is a perfect square. The second term is not a perfect square. But even if it were, we could not factorize it on the basis of 2 squares. So I'm saying that this first term is a perfect square. This one is not a perfect square. And I'm saying also that even if both terms were a perfect square, we still could not factorize the expression of the basis of 2 squares. The positive sign that separates the two terms negates any prospect of factorizing it based on the premise that it has 2 squares. So this positive sign that we have here negates any prospect of factorizing the expression based on the premise that it has 2 squares. The fact is, a sum of 2 squares does not have real factors. So if we had, say for argument's sake, a 25 here, which is a perfect square, we have this first term a perfect square, this second term a perfect square, we still would not be able to factorize the expression on the basis that it has 2 squares. The fact is, a sum of 2 squares does not have real factors. And notice that I'm saying real, because a sum of squares has factors, but we do not take a look at the factors of a sum of 2 squares at this level, because the factors of a sum of squares is what we call complex numbers, and complex numbers have a portion that we define to be imaginary. So a sum of squares at this level, we will say that it cannot be factorized. But in mathematics in general, we will say that it does not have real factors. Therefore, the positive sign is the first indication that we cannot factorize a binomial on the basis that it has square terms. We therefore do not need to look beyond the positive sign. We will take a common factor of y. So as long as you see 2 terms in any expression in the examination, 2 terms, a binomial, you cannot factorize that even if the 2 terms are square. You cannot factorize it on the basis that the terms are square, because you know you can only factorize a difference of 2 squares. Therefore, if you will factorize an expression on the basis that the terms are squared, you need to factorize it as a difference of 2 squares. and the positive sign that we have here prevents it from being a difference. Therefore, it cannot be a difference of two squares. The only way that we can factorize such an expression at this level, as according to the requirements of the CXE CSEC examination syllabus, we can only take a common factor, and we take a common factor of y, and y will cancel one of these occurrences of y, so we will have 4y, and any number or expression divided by itself is equal to 1, so we will just have 4y minus 1. 4y squared divided by y is 4y, and y divided by y is equal to 1, and that's all there is to it. The product of a and c in this trinomial is 6 times negative 5, which is equal to negative 30. A negative product indicates that the two middle coefficients will have different signs. So we are sure, because of the negative product, that the two numbers will have different signs. The value of b is positive. This tells us that of the two middle coefficients, the larger one is positive. So consider the possibilities. So we will actually, on this occasion, take a look at the pairs of factors of 30. That is, take a look at the numbers that we take in pairs that multiply to give 30. For sure, we are talking about a negative 30. The two numbers will have different signs. And the middle term, which is the sum of the two numbers, is positive. Therefore, we are sure that the larger one is positive. So, let us look at the possibilities as we said before. So, we know that if we have 30 multiplied by 1, that is 30. The larger one is positive. 30 minus 1 is 29. Here we have 10. If we multiply that by 3, we'll get 30. They need to have different signs, so 10 minus 3. And also, the larger one has to be positive. As we said before, two of them have different sign, and the larger one is positive. And we do the same. Sometimes, well, when I'm doing my factorization practices in class or exercises in class, the students, most times, they do not write anything down. So I will say, what two numbers multiply to give a negative 30 and add to give a positive 13? And they just sit there for a second and a half, and by that time, some students will arrive at the two numbers already. And for the most part, when students have a difficulty arriving at the two numbers, they have that difficulty because they are not sharp on their multiplication tables. The same ones that we call timetables. They do not know their times tables. Therefore, they will have some difficulty factorizing a trinomial in good time. So it is always very important, not for this only, but for mathematics in general, manipulation of fractions and so on, if students are sharp on multiplication tables. Of old, my classmates and I were very sharp on multiplication tables, and now we find students going through high school without knowing their multiplication tables. And we know the policy that is in place that is causing students not to be as sharp as before on their multiplication table. Therefore, we have a decline in their general ability to master the subject. And I do not need to say more. When that issue is addressed again in the next 50 years, then we will have students being sharp on their multiplication tables again. But I do not see that happening in the near future because of a single policy that needs to be addressed. So we have identified the two numbers that have a product of negative 30 and a sum of positive 13. So no doubt they are positive 15 and negative 2. It is not necessary to always accompany a positive number with a positive sign. That is why we have the 13 here, not accompanied by a positive sign. The default sign is positive. The pair that gives the correct answer is positive 15 and negative 2. Those will be the coefficients of the components' middle terms. And we will see those on the next slide. Maybe one reason for the examiners giving a problem like this one, 6x squared plus 13x minus 5. Students or some candidates may not consider the signs too seriously and not giving the necessary respect that is due to the signs. They may make a mistake. For example, if they did not consider the sign, they probably would have said 10 plus 3 is equal to 13, and they may attempt to factorize the expression with a positive 10 and a positive 3 because they give 13, positive 10 and a positive 3. Do not forget that the two numbers have a negative product, therefore they must have different signs. Therefore one could not use 10 and 3 to give 13 because they will have to have the same sign. So that cancels our thoughts about a positive 10 and a positive 3. Also, when we are factorizing a trinomial, if we have here, as this is given, with the exception that we have a positive 10 here and a positive 3, then we cannot factorize by grouping. We will not be able to factorize by grouping because we would have one positive sign, two positive signs, and another one, three positive signs, and a single negative sign in the expression. And we cannot factorize in groups of 2 if we have 3 positive signs and 1 negative sign. All of the signs will have to have a pair. So if we have so many positive signs, then all of the signs would have to be positive, because we can take 2 positive signs and 2 positive signs. We can take a negative and a positive. We can take a negative and another positive. We may also take 2 negatives and 2 positives, as we have right here. But surely we cannot take 2 positives and then take a positive and a negative and expect that factorization by grouping will actually be correct. So the signs also play a very important role in determining if we are on the right track. So we know that our middle components are positive 15 and negative 2. And the first common factor that we apply to the first pair is 3x. And what do? We divide each term by the highest common factor. So we say 3x into 6x squared. 3 into 6 is 2. X into x squared is x. So we have 2x. And then we say 15x divided by 3x. 3 into 15 is 5. And the x's will cancel. We have 5. On the other occasion, what do? Take a common factor, right? And we normally use the sign that begins the second pair. So we will use what? A negative sign. But can only find 1 as a common factor. So we say negative into negative is positive. and 1 into that thing is the same thing. So we have 2x. Negative into negative is positive, and 1 into anything is that same thing. So we have 5. So we will have a 2x plus 5 in the end. Take it a bit further by making use of the common factor of 2x plus 5. There we have 2x plus 5 is our common factor. And then what do we do next? After dividing each term by 2x plus 5, the other factor will be 3x minus 1. 3x minus 1, there. 3x minus 1 highlighted, 3x minus 1, there. Here is another difference of two squares. In the examination, we are required to factorize such expression at sight. We should therefore take one step. Also, we do not expect to be awarded more than a single mark for solving one of these problems correctly. Difference of two squares. Take the square root of the squares. So proceed by finding the square roots of the squares. They will be enclosed in brackets and be separated by a negative sign in one case and a positive sign in the other. So what is the square root of a squared? That is a. And what is the square root of 9? 3. And we do like that and put our signs there, and that's all there is to it. Let us proceed to factorize the new expression by grouping. So we have another expression that we will factorize by grouping. Let's go straight ahead. The first two terms have a common factor of 3a. And what do we say? 3 into 6 is 2. A will cancel a, and all that is left is p. So we expect 2p. 3 into 15 is 5. And the a will cancel, so we have 5. So we expect to have 2a plus 5. So 6ap divided by 3a is equal to 2p, and 15a divided by 3a is equal to 5. On the other occasion, what do we do here? Take a common factor that has the same sign as the sign that begins the second pair. So the second pair has a common factor of -2. And what do we say after that? Negative into negative is positive. 2 into 4 is 2. Nothing to cancel the p. It goes back 2p. Negative into negative is positive, and 2 into 10 is 5. 2p plus 5 again. Take it a bit further by making use of the common factor of 2p plus 5. 2p plus 5 is our common factor. And what do we have left there? After dividing each term by 2p plus 5, the other factor will be 3a minus 2. Do not forget that when we are factorizing, we are actually dividing by the highest common factor. So this will cancel with this, of course, and we have 3a, and this one will cancel with this one, and we have a -2. Now, we are not demonstrating this right here that we are actually dividing. We are not showing the intermediate step, but we have done that before. And I am attempting to have the two steps written down without showing the intermediate step, but at the same time I have to show you the way that we have to think, because I cannot think it and imagine that you will understand. So we have here notations of what we are actually doing in the intermediate steps, because I am opting not to include the intermediate steps here. As a matter of fact, we have gone through quite a few videos in the tutorial so far, and as a matter of fact, for some of them we have shown what the intermediate steps should really be like, And as a matter of fact, before we are through with these video presentations, we will see some more. The next expression, let's see what it is. No one should find another difference of two squares to be overbearing at this stage, especially that we all can factorize it at a glance, and also that we will be awarded marks for doing so. Right, so if we have a mathematics examination with only easy problems, then we are happy, even if the problems are boring, because we will pass our examination and we'll get our marks. The difference of two squares, we may factorize at sight. So even though we have seen 1,000 of them before, then I'm sure that if we are about to be awarded marks, no matter how many of them we have seen before, we will want to be able to factorize this one in order that we will get the marks. So we will go straight ahead and factorize the difference of two squares by finding the square roots of the squares. They will be enclosed in brackets and be separated by a negative sign in one case and a positive sign in the other. Square root of 4x squared is equal to 2x, and square root of y squared is equal to y. Square root of 4 is 2 and square root of x squared is x. No difficulty. We'll have them enclosed in brackets. The square roots are enclosed in brackets, and we will separate them by a positive sign in one case and a negative sign in the other. No matter how many marks will be awarded for the factorization of a difference of two squares, there are still some of us who will say that we have had enough of them in these tutorials. No matter how many marks are awarded, some students and some mathematics campers will imagine or would want this one to be the last one that we have seen. But I am just going through the tutorials. All of the problems that we have here will be solved. Let us proceed to factorize the new expression by grouping. So we have 6m plus 4n minus 9km minus 6kn, and we will factorize by grouping. And what will be our first common factor? Something that can divide into 6 and 4, the largest such number. For sure, this part is not affording us any more addition to our common factor, because here we have an m and an n, so the only highest common factor is 2. So the first two terms have common factor of 2. There is our highest common factor of 2. So we will divide each one of those terms by the highest common factor of 2. So we have 6m, and the 6m divided by 2. 2 into 6 is 3. Nothing to cancel the m. It will go right back. Also, we have 4n. The same thing will happen there. 2 into 4 is 2, and nothing to cancel the n. It will go right back. For the second pair, we have a little bit more sophisticated common factor. And the common factor on this occasion should contain what is common? K is common. And also the largest number that can divide into both 9 and 6 without leaving a remainder. That's a 3. And we should also be mindful that we need to take the sign that begins the second pair, and that sign is negative. So our second highest common factor is negative 3k. And as usual, we will divide each term by the highest common factor. Now, we can take the things together in order that our work may appear to be a little bit simpler. So we will say negative into negative is positive, negative into negative is positive, and in each term the k's will cancel. So all that we have left is to say that 3 into 9 is 3, and the m will return 3m, and we say 3 into 6 is 2, the n will also return. So we have 2n, like we have right there. And it is always an indication that we are on the right track if we legitimately arrive at the second factor, and in that bracket we have the exact same expression as we have in the first brackets, as long as we do not force an issue and cause them to be the same erroneously, then we are on the right track. And one way that we can do that, or the circumstance that might give rise to the fact that we might need to make some adjustments that are not legitimate in arriving at the same expression in both brackets, may be that when we are factorizing a trinomial, we resolve the middle term into its two components, and we resolve them erroneously. Then maybe we'll have to make some adjustments that are not legitimate in arriving at the same expressions in both pairs of brackets. But as long as we are doing everything the right way, we are always going to be convinced that we are on the correct pathway if the two pairs of brackets have the same exact expression. And negative 9km divided by negative 3 is equal to 3m. Negative 6kn divided by 3k is equal to 2n, as we discussed before. We will take our factorization a bit further by taking a common factor of 3m plus 2n. And on this occasion also, we are eliminating the intermediate step, but at the same time we are making mention of it, or giving some indication that the process is actually carried out. We have these terms highlighted because those two terms will occupy the second pair of brackets, and they will do so legitimately because we have taken our highest common factor and we are dividing by the highest common factor. So if we say 3m minus 2n into this expression, these will cancel and we have 2, and also we'll cancel here again and we have a negative 3k. So we will have 2 minus 3k occupying the second pair of brackets. And if my memory serves me right, on a previous tutorial we have solved this problem. So we'll just take a second go at it, include the details as usual. For this trinomial, the product of a and c is 2 multiplied by negative 6, and that gives us a negative 12. The product is negative, and what do we know about a negative product? If we wish to be consistent, getting that negative product all the time, then the two numbers that we will use will have to have different signs. So we know that the numbers will have different signs. That is for the negative product. And the middle coefficient, which is b, is positive. Therefore, we know that the larger number of the two is positive. But we have concluded already that one is positive and the other is negative. We have concluded or come to that conclusion based on the fact that the product is negative. Product is negative, numbers have different sign. Sum is positive, means that the larger one is actually positive. So we'll take a look at all of those numbers. So we will consider the pairs of numbers that will give a product of 12. What are the pairs that will give a product of 12? First of all, we have 12 multiplied by 1. Then we have 6 2's. Then we have 4 3's. The middle coefficient is positive, therefore the larger number is positive. Remember that they must have different signs because the product is negative. The middle coefficient, which is the sum, is positive. The larger one has to be positive. So we will put a positive 12 with a negative 1, a positive 6 with a negative 2, and a positive 4 with a negative 3. And those are all of the results. And which one gives us a coefficient of a positive 1? A term that is not accompanied by any coefficient has a coefficient of 1. Also, there is really no need to go through a long, lengthy or technical process if the coefficients of the middle components may be identified immediately, which is what a candidate should be able to do if he or she is sharp on the multiplication tables, the same ones that you call timetables. If you are sharp on your multiplication tables, then when you are factorizing a trinomial, you will have less difficulty than the other candidates who are not so sharp. So let us continue. After we have resolved the middle term into its two components, let us factorize by grouping, taking two at a time, and the common factor of the first pair is a. So we take our common factor of a and we divide each term by the highest common factor, and we are maintaining the presence of our highest common factor right there. So divide each term by the highest common factor. We go over to the second pair. The highest common factor is 2 on this occasion, and we'll take our highest common factor of 2 and we maintain its presence, and we also divide each term by the highest common factor. So divide each term by 2. And what do we know? The a's right here, a into a squared is a, so we will have 2a. The a's cancel here, we just have 3. 2a minus 3. So we have 2a squared divided by a is 2a, negative 3a divided by a, as we said before, and negative 3, 2a minus 3, that will be the first one. And in the second case, we expect 2 into 4 is 2, nothing to cancel the a, we get 2a, and 2 into 6 is 3, not neglecting this negative sign, we have a negative 3. So we have 2, our highest common factor, we always carry it along with us, and we have 4a divided by 2, 2a, negative 6 divided by 2 is negative 3, as we have them right there, and that will be our next term. Finally, the common factor is 2a minus 3. So the common factor is 2a minus 3, and if that be the case, then we will have to divide each term in the resulting expression by 2a minus 3. Yeah. So we have 2a minus 3 is our common factor, and we are dividing each term by 2a minus 3. The 2a minus 3 will cancel right here. All that we have there is a. And the 2a minus 3 will cancel right there. All that we have there is 2. a plus 2. We are almost at the end of these tutorials and should surely be at the stage that we should be able to look at an expression and determine its factorization requirements. There is therefore no doubt that we should see immediately that we should take a common factor of 7p. So take a common factor of 7p. 7p goes there. That is our highest common factor, because largest number that can go into 7 and 14 is 7 into m and m squared. That is the largest power of m that can go into m, and m squared is m, and also p squared and p. We have this, and this is quite analogous to quite a few of the expressions that we have factorized so far. And because of the analogy, we expect that in the case that we have the p squared, we will just have p, and in the case that we have m squared, we will just have m. So divide each of the terms of the original expression by the highest common factor. 7mp squared, 7 is gone, m is gone, and then we have p into p squared is p. And 14m squared p, 7 into 14 is 2, m into m squared is m, and the p's will cancel. And that's all there is to it. So far, we have shown from purely theoretical standpoint how we may arrive at the HCF. Before the end of these tutorials, we will look at a simple rule of thumb that we may apply. So we will take a look, or a simplified look at the way that we may arrive at our highest common factor, because we have taken I would consider to be somewhat of a highly theoretical approach in finding the highest common factor, but we make use of a particular rule of thumb before these tutorials are through, that one may find it a little bit easier arriving at the highest common factor. This time AC is equal to 2 times 15, which is equal to 30. A positive product indicates that the two numbers have the same sign. B is negative. This tells us that the two numbers are negative. So do not forget that if we have a positive product that we do right here, A is 2 and C is positive 15. Therefore, we are sure that the product is positive 30. And if the product is positive 30, what do we know for the positive product? The two numbers must have the same sign. And if the two numbers have the same sign, the middle one is negative. We cannot add two positive numbers and get a negative answer. We will have to add two negative numbers, because the two numbers must have the same sign. We have established that already. So let us go straight ahead. So the two numbers will have to be negative. We are saying, without going through the entire list as we have done already through these tutorials, we are not going through the entire list on this occasion. Negative 6 minus 5 is equal to negative 11. And so we have identified already the two coefficients of the component middle terms. The coefficients of the component are negative 6 and negative 5. Although we cannot always depend on it, there is only one option that we have for the combination of factors of 30 to give a sum of 11, and that is 6 plus 5. Or for the negatives, because we have two negative numbers, for negative 11 we have negative 6 minus 5. Sometimes we may use the fact that among the factors a particular sum may be unique. that will eliminate all other possibilities. Sometimes we have ambiguities and we need to be extra careful. So what I'm saying is that we know that if any combination at all for all pairs of factors of 30, the only pair, whether adding or subtracting, will give 11 is negative 6 and negative 5, or 6 plus 5. And of course we are adding 6 and 5 in that particular case, only that we are adding the negatives of them. So the only combination of factors of 30 taken two at a time that will give a sum of 11 is 6 and 5. So that eliminates everything else. And I'm saying that we can make use of the fact that a particular sum is unique. I'm also saying that we have to be careful in the event that we have ambiguities. And as a matter of fact, as far as the product 30 is concerned, we have ambiguity in 30, because we have 3 plus 10 is equal to 30, 3 times 30, and we have 15 minus 2 is equal to 13. 15 times 2 is 30. So we have 10 plus 3 and 15 minus 2 giving the same sum. So we have to be careful in the event that we have ambiguities. But in this particular case we are safe, because only a sum of 6 and 5 among all of the factors of 30 taken two at a time will be able to give us a sum of 11. So we can just zero in on that particular pair, because we are sure that there is no other. Now that we have resolved the middle term into its two components, a negative 6y and a positive 5y, let us proceed to factorize. The first two terms have a common factor of 2y. 2y into 2y squared, as we can see. 2y into 2y squared, the 2's are gone. Y into y squared is y. 2 into 6 is 3, and the y's are gone. So there we have it. 2y squared divided by 2y is equal to y. And negative 6y divided by 2y is equal to negative 3. 2 will cancel there, and y into y squared is y. Here we have 2 into negative 6 is a negative 3, and the y's will cancel. So we have y minus 3, and we will proceed by taking the common factor of the second pair, and the highest common factor of the second pair is negative 5. So take negative 5. What do we get? Negative 5y divided by negative 5 is equal to y, and 15 divided by negative 5 is equal to negative 3. We could have seen it from here. Negative into negative is positive, and the 5's are gone, and we have a y. And negative into positive is negative, and 5 into 15 is 3, negative 3. So no doubt we have it correctly done right there. So finish up our factorization process by continuing to take the highest common factor where it exists. Here the highest common factor is y minus 3, so take our y minus 3, and we will divide. When we take our highest common factor, we maintain it right there. We do not leave it out, as it is the custom of some candidates to do. So take our highest common factor and divide each term by the highest common factor. Y minus 3, y minus 3, those are gone, and the same thing will happen here, and we have 2y minus 5. So 2y minus 5. And that is all there is to it for tutorial 4 in factorization tutorial.